This is our example number 10. In a standing wave, the displacement of particle at x at time t is given by y xt is equal to a sin bx cos cx, where a, b, c are constants, and find the dimension of b by c are same as those of wavelength. B is 1 by wavelength, c is wave velocity, or d is 1 by wave velocity. We have to find out the value of b upon c. So we know that here the solution of the given equation is y of xt is equal to a sin bx plus into cos ct. So we know that the function of sine and cos are dimensionless. So the value of bx and ct are also dimensionless. Here b is equal to 1 by x and c is equal to 1 by t, where x is the form of length and t is time. So b is equal to 1 by L and c is equal to 1 by t. If we find out the value of b by c, then here we get 1 by L upon, if we write here 1 by t, that is equal to 1 upon L into t inverse. This is the form of the value of velocity, the dimension value of velocity. So here we can write 1 by v, or the value of velocity or 1 by. Example number 11. When a liquid of coefficient of viscosity neta and density rho flows through a pipe of radius r, the flow remains streamlined if its velocity does not exceed a value Vc given by Vc is equal to k neta upon rho r, where k is Reynolds constant. We have to show that k is dimensionless. So the solution is here. The solution is here, like the given equation is Vc is equal to k neta upon rho r. If we find out the value of k, that is Reynolds constant, that is equal to Vc rho r upon neta. So the dimensions of all these values, like Vc into rho into r upon neta, the dimensions of all values we have to put Lt minus 1, the velocity, the dimension of velocity, and the dimension of viscosity, density. Sorry, here rho is density. So the dimension of density is m, L minus 3, that is mass per unit volume, and r is form of length upon neta. Neta is the value of viscosity, and the coefficient of viscosity we already find this value, that is m L minus 1 t minus 1. After this solving these values, we find out the value of k is, like here m cancel, here L3 minus 3, we solve it L1, here L minus 3, the value of here plus 1, and this is also plus 1. Here the value of t is t minus 1, and this value going to up, then plus 1, and m1 minus 1. So here we can find out the value of m naught, t naught, and l naught, because these all are cancel out the values. So we already find out this value of the coefficient, Reynolds constant, which gives the value is also dimensionless. Thank you. Next example is example number 12. Find the dimensional formula for electric field E, magnetic field B in terms of M, L, T and A, where A is given dimension of electric current, or we can say that A belongs to ampere. The solution is here we know the formula of electric field, that is equal to force per unit charge. So this implies we can write it in the dimension form. Then the value of E is equal to F upon Q. So this implies the current is equal to charge per unit time. We know that the value of current, that is equal to charge per unit time. So I is equal to Q upon T. This implies we find out the value of Q, that is I into T. So the value of I is that already given that dimension of electric current, that is in form of ampere. So here we write the A and T is capital T. So here we put this value in this equation number 1. The value of Q put in the equation number 1. E is equal to F upon Q. As we know already, the value of force is M L T minus 2 upon Q is the value of A into T. By solving this value, we got the result is M1 A minus 1 L T minus 2 minus 1. So the result is M L A minus 1 T minus 3. This is the value of electric field. The second one is question number B is find out the value of magnetic field in terms of M, L, T and A. So the magnetic field is, we can find out the value of magnetic field by this formula, F is equal to Q into V cross B, where these are both are the vector forms. So F is equal to Q into V cross B. If we find out here the magnitude of F is equal to Q VB sin theta. Here since the sin theta is dimensionless, so F is equal to Q VB sin theta. So sin theta is dimensionless, then we find out F is equal to Q VB. Here B is equal to F upon Q by V. We already find out all these values, and the value of F is here already putting M L T minus 2 and upon Q is A into T, and the value of V is distance per unit time, so L T minus 1. After solving this equation, we find out M1 A minus 1 T minus 2 minus 1 plus 1 and L having the value 1 minus 1. So the result is M1 A minus 1 L0 T minus 2. This is the value of magnetic field, the dimension value of magnetic field. Thank you.